Assalamualaikum, my name is Nur Magdalene Zizi. My matrix number is Cn2100. Right now I'm going to present my work of Lab 5, which is standalone solar PV system using PV system. So firstly, I'm going to answer all the questions part. So the first question is, what is the standalone solar system? Basically, a standalone system always organized around the battery storage. A PV array charge the battery or directly deliver its power to the user, and the user's needs should be well defined with its daily profile. In the example, hourly value. In short, the solar panels are not connected to the array, but instead are used to charge a bank of batteries. Questions number 2. What are the components of standalone system? So basically there is 3. Firstly is the PV models, batteries and charge controller. Questions number 3. Draw a diagram to show connections of solar load. The load are basically based on my applications or output that in my room right now. So according to the diagram, I only apply two output, which is LED and fans. And my chosen house area is at Rantau Panjang, Kelang. And questions number 4. Explain the tails angles and azimuth angles. So basically, the tails angles is the angles of PV modules from the horizontal planes for a fixed modules, whereas the azimuth angles is the angles of the PV modules relative to the directions of south. Negative 90 degrees is east, 0 degrees is south, and positive 90 degrees is west. So basically, the tails angles is describe the verticals angles of the solar panels, and azimuth angles is the horizontal facing the relative to the equator. And finally, questions number 5. What does horizon means in solar system? So basically, in short, the horizon is the line that separate the earth from the sky, and there's two main types of horizons, which is earth sky horizons and celestial horizon. And both earth sky and celestial horizons have different types of horizons. In addition, the horizons is a broken line superimposed on the sun path diagram, which can hold any numbers of height points. Right now I'm going to present task 1. So firstly, we open the PV systems software and click on the standalone. Rename the project names as task 1, and we select the locations. As for my place, I have to add a new area to be inside the system, as I want to design a system. After that, I save the file and we open it back, and moving to the orientations. Here is the part that I have to adjusting the tails angles and the azimuth angles. And I choose summer, April to September, because right now it's summer and April. I adjusting the angles of tails is 15, and after that no error is appear, and I'm moving to the user's needs. At the user's needs, you can put every daily consumptions of your applications, how many applications that you want inside the system. This one as the examples, whatever applications output you want to put, and the power and everything. Right now is the part to adjusting the hourly distributions, how many hours that you use the applications per day. Then after that, you save it, and I choose kind of load profile at the load value from CSV hourly and daily file, and I choose the household and we scan it to my data, and I can get the CSV source of file data that are from my applications, and I save it. I'm moving to the system. The system I choose, I choose the battery set to genitals, and it's automatically set it's on, and I'm moving to the PV array. I'm using MPPT converter as my PV modules, and 60 watt power in the PV modules. And after that, you can run your simulations to create to design your system and finish the task one, and you can convert the report simulations into PDF, and everything is provided inside there. Moving to the part 2, I create a new file of project and rename it as task 2, and select the locations of my place and save it and reopen it back. I'm moving to the orientations part and adjusting what is needed according to my data and users needs. I insert all the output that I have inside my room, which is one lamp and one fan, as the power for my lamp is 2 watt and the power of my fan is 75 watt, and daily use for my lamp is 5 hours per day, and daily use for my fan is 24 hours per day. And my hourly distributions is how many hours I've used the applications as for my lamp and my fan. And I save it. I'm moving to the last part, which is system. I adjusted the battery set into genital, and it's automatically changed into 25.6 volt, and the model in series is 1 and 3 in parallel. I'm moving to the PV array. I choose the PV modules is MPPT converter and 60 watt power of the PV modules, and I save it and I completely run the simulations and getting my result. As you can see at the loss diagram, my missing energy is 0.3% and 2.7 kilowatt, and others is fine. Efficiency energy at output as shown in the diagram, and I can convert all this result data into PDF document. As for the discussions, a standalone solar PV system is self-efficient energy generation systems that is not connected to the main power array. It's basically produce electricity through the battery stores that stores the essence energy from the solar panels. PV system software allow the user to simulate the performance of solar PV systems under different weather conditions and optimize system parameters such as the panel orientations, tails angles, and battery capacitor. In this lab 5, it's provide a detailed analysis of the system performance, include the energy generated by the solar panels according to the chosen area of my place, which is Rantau Panjang. The energy consumed by the household and energy stored in the battery bank. The PV system software was used to simulate the system performance under different weather conditions, including the sunny day, cloudy day, or rainy days. The result of the simulations showed that the systems are able to generate superstitions of energy to meet the household energy demands even on the cloudy and rainy days. The battery bank was able to store excess energy generated during the sunny day, which was then used to power the household during low sunlight period. And the result of this also provide an analysis of the system efficiency, including the energy conversions and efficiency and overall system efficiency. It's also conclude that standalone solar PV system using the PV system software is able to meet the energy needed at the small household, even under different kind of weather conditions. The system performance be able to optimize by adjusting system parameters such as panel orientations, tilt angles, and battery capacitor using the PV system software. In this lab, it's a highlight the importance of using advanced software tools such as PV system software to design and analysis a solar PV system to ensure maximum efficiency and optimize performance of the system. The conclusions of this lab, I able to learn the simulations of standalone PV solar system by using the PV system software, and I be able to discuss the result external from the simulations process. In conclusion, the standalone solar PV system by using the PV system software provide valuable insight into the design and performance of renewable energy system, and the result of the simulations inside this lab shows that the system was able to meet the energy needed in small household even under different kind of weather. And the use of the PV system software allowed to optimizing of the system parameter and maximize the system efficiency, such as it can help to promote the adoptions of renewable energy system and contribute more sustainable future.